Welcome to the university, and in this video we are going to answer the question, how strong is the electric force compared to the gravitational force? But before we do this, please extend your appreciation and give us a like, share our contents, and don't forget to subscribe to the university, and don't forget to hit the notification bell to get updated whenever we post videos like this. So let us start our journey by making a comparison between the magnitude of the force of gravity and the electric force. So I have here a formula which is Fe all over Fg, and we know that Fe is the electric force and Fg is the force of gravity, and it has an equivalent formulation of Fe for the numerator all over our denominator, which is Fg, and it has an equivalent form of for Fe we have K times the magnitude of Q sub 1 times Q sub 2, wherein Q sub 1 is the magnitude of the charge of the proton because that's positive, and we have the magnitude for the charge of the electron because that's negative. And here R is the distance of separation between the two charges, and K is just a constant. And later on, I'm gonna reveal the value of K. So for the force of gravity, we have G here, which is the universal gravitational constant calculated by Henry Cavendish. And since it involves gravity, we need the mass of the proton and we need the mass of the electron, and we have to multiply them and divide them by the distance of separation, r squared. Alright, so let us simplify this formula by multiplying the numerator. So this part should be multiplied to the denominator and create the new numerator, which is K times Q sub 1 times Q sub 2 times r squared, and the denominator of the numerator times the numerator of the denominator. So that would create the new denominator, G times m sub 1 times m sub 2 times r squared. Alright, so I hope you follow that, and then you will see that r squared will cancel out because they are the same term or similar term, and r squared divided by r squared is just equal to 1. Alright, so let's proceed and substitute the value. But first, let us see the simplified equation. Fe all over Fg will look like this. Yeah. Yep. So, and then from here on, we are going to substitute. Alright, so K has a value of 8.99 times 10 to the 9 Newton times square meter all over coulomb squared. So the value of the charge is 1.6 times 10 to the negative 19 for the proton. It's also the same value as that of the electron to make the atom electrically neutral. Alright, so that's equivalent to saying 1.6 times 10 to the negative 19 c to the power of 2. So c to the power of 2 all over c to the power of 2 will cancel out. Alright, so what will remain here in the numerator as a unit is Newton times square meter. Alright, so what we're gonna do right now is multiply 8.99 times 10 to the 9 times 1.6 times 10 to the 19 raised to the power of 2. Alright, so you just have to make sure that you execute the exponent first before the multiplication. Alright, so here in the denominator, value of G is 6.67 times 10 to the negative 11 Newton meter squared. Alright, all over kilogram squared or squared kilogram. Okay, so right now we have the mass of the proton, which is 1.67 times 10 to the negative 27 kilogram times 9.1 times 10 raised to the 31 kilogram. So kilogram times kilogram is kilogram squared. So you will see that the term will cancel out, and what remain here in the denominator is Newton times square meter or meter squared, and this will also cancel out. So since there's no unit, this is just a pure number. Alright, so next step is to press this in your calculator, and you will see that the answer is Fe is 2270 times 10 to the 36 times stronger than the force of gravity. So it's much stronger. compared to the force of gravity by a factor of 10 to the 36 times, all right, or 10 to the 39 times if you round up to 0.270 times 10 to the 39, all right. So this is the answer. It is 2270.47 times 10 raised to the 36 times stronger than the force of gravity. So thank you guys for watching the university. I hope watching this video and staying with the university. So please don't forget to click the subscribe button, hit the notification bell, give us a like and share our content so that others will learn about our channel. Alright, so bye bye. Hope to see you soon again in the university.